Good afternoon to all.
Good afternoon, sir.
Now let us discuss about the design thinking based noise pollution monitoring system for smart cities. See, noise pollution is one of the most critical, crucial environmental challenges in digital signal processing. See, arise from vehicular traffic and then construction activities, industry operations and public gatherings. So how we are adding means this prolonged high noise signal arises from leads to like hearing impairment and then reduced quality of life and then stressful environment, right? Here we are using the design thinking based approach for noise pollution monitoring system. We are giving the solutions, right? Now let us discuss briefly about design thinking is of 5 stages: empathy, define, ideate, prototype and design. Let us discuss briefly.
Let me explain about the empathy part. In empathy part, we can see about the core problem statement. Like in cities, there are a lot of noise pollution occurring at even nights. So we can solve using the DSP. Like we are using some terms such as FFT, fast Fourier transformers to display in digital signal processing, or it can be rectified. Where it can convert the noise signals from the noise waves to the decibels levels. For example, a resident living in a home, at the night even they can see how much decibels the noise are occurring. We can see about detail in the later parts.
Discussed about the defined part. In the defined part, insects gathers are converted as into engineering problems. Like the problems are design smarts, and in the DSP, digital signal processing, which is based on to control the noise monitoring systems, based on the real-time occurrences and the system affections, etc. And in also integrating smart cities to support the noise controlling monitoring systems. And the designing spots are conventionally included in the cost effectiveness, low power consumption, reliability, and real-time occurrences also.
In the noise level pollution systems means how to monitoring with the help of digital signal processing by using the analog to digital conversion. Why we are using means first we can finding the analog signals that can be converted into digital signals. Why we are converting means to analyze the frequency level. How the frequency time domain analysis that can be converted into frequency analysis with the help of fast Fourier transform. And also we are using it as your aliasing. Aliasing we can use it before sampling. How to reduce the noise level during for smart cities, right? That reducing level means how we are using means to reduce the distortion in terms of noise pollution monitoring system. And also we can use it as in terms of FIR and IAR filters. See, FIR and IAR filter means why we are going to analyze these type of filters for noise monitoring system means how to reduce it with the help of by applying in terms of low pass filter, band pass filter, band stop filter and high pass filter. By applying all these signals into a frequency domain analysis, we are in this way we can reduce the noise level monitoring system.
Next is the ideate stage, and in the ideate stage, different solutions are developed using digital signal processing, in which is to analyze noise. Noise can be measured using root mean square and sound pressure levels, and also by applying digital filters, we can isolate noise bands, and also with the help of feature extraction, we can identify noise sources. And a simple IoT-based monitoring system is also used in smart city noise control applications. And core DSP topics like sampling, filtering, and quantification, and also spectral analysis can also be used.
Let me explain about the prototype stage, the system architecture, and the signal acquisition. We all know that in the prototype stage, we built a working model, how the system performs and how it works. So surrounding noise is actually observed by a microphone sensor that converts the sound waves into an electrical signal. Actually, that electrical signal is very lower strength, so it is amplified using a conditioning circuits. Before this signal is converted into digital signal, we are using an anti-aliasing filter to remove the unwanted noise from the signal. So that filter signal is now converted into the digital signal using a ADC, analog to digital converter. This represents a real-time environmental noise. And in the DSP processing, this digital signal is converted into a sound waves in decibel levels. So this makes to monitor the noise level is always within the allowed limits and make them suitable for the real-time applications.
Time domain noise measurements. From the time domain, they can convert them into frequency domain in terms of fast Fourier transform. See, time domain noise measurements using root mean square to sound pressure level calculations. By using FFT means we can converting from your time domain to frequency domain. Why we are converting means to reduce the noise selection. And digital filtering isolating specific noise bands. In terms of bands means low pass filter, high pass filter, band pass filter, band stop filter. See, each and every filter has some type of bands. And also future extraction for noise identification. And also linear phase FIR filter means we are using for low frequency traffic noise and broadband construction noise and mid frequency human activities noise. It also, why we are using this type of linear phase FIR filter noise monitoring system is to improve the clarity and accuracy in noise interpretation.
So next we are going to see about the time frequency and noise classification. The time frequency where the sound is being classified with the help of FFT, that is fast Fourier transform, in which it isolates the sound and classifies into different modulations. For example, low, high and mid frequencies. Low frequency is, for example, it's traffic and engine sounds, and high frequency is the high pitch sounds like whistle sound and other machinery sound that produces high thing, and mid frequency is the human activities and voices that we speak by humans. Where with the help of FIR filters, it is used to isolate with the help of in a frequency manner. So these frequency manner is sent into a data and classify from which the sound is being get exposed very loudly. So that that has been explained in the noise classification part, where each sound has been segregated in a proper frequency level. So if the frequency level exceeds more means it gets notified with the help of alerting system to the mobile phones and other nearby electronic gadgets. So it tells from which part it gets noises will exceed. For example, if the construction part has more amount of decibel sounds means it gives a message to the construction site, and also if a party or as a traffic area gets more amount of noise means it gives gives a notification to the machines and also the vehicles and mobile phones.
Let us see about the test stage performance evaluation. The system is based on the tested using real environments like the busy roads, residential and industrial areas at night time, and its performance is evaluated by using the SPL accuracy and the classification accuracy and frequency response and response time and reliability, and evaluated using the international and national noise standards.
Now let us conclude the design thinking based smart pollution monitoring system for smart cities. See here, by applying all these, why we are integrating DSP in noise pollution monitoring systems. To first we can analyze with the help of time domain. See, time domain from root mean square to sound pressure level, and then FFT. FFT means from fast Fourier time domain analysis to frequency domain analysis, and also digital filtering. How we are applying digital filtering means with the help of IDC converter and sampling process. Why we are applying means from analog to digital. Why all these applying in your digital signal processing in terms of IAR filter and FIR filter means to reduce the distortion. Okay, to reduce the distortion, and also we can analyze the frequency levels in terms of low, mid and high frequency levels. By incorporating all these digital signal processing techniques can be applied into noise pollution monitoring system means we can improve the life of your human, right? This is the design thinking based noise pollution monitoring system for smart cities. Thank you all.
Thank you, sir.